Alright, so where we left off was we found the frequency of the green light given to us in the question and where to plug it into the equation. So we're using the energy equation, and that's because the question is asking us first to find the energy using the frequency. So we plugged in frequency, which is 6 times 10 to the 14, and then we plugged in our constant, which is h, 6.626 times 10 to the negative 34th. Now, to actually calculate this in your calculator might be the tricky part for you because we have scientific notation and you have to be able to put it in your calculator correctly. So depending on your calculator, you might have to do scientific notation differently. So I recommend you look up your model. You can Google your calculator model and Google how to do scientific notation, and make sure that you use lots of parentheses to not confuse your calculator. So I can just write that. You can put parentheses around your whole entire constant so that it knows that you want to multiply this whole thing by this whole thing, your whole frequency, okay? So your calculator doesn't get confused. Once you do that, I'm going to go ahead and put this in my calculator. Times 6 times 10 to the 14. I've got 3.98. If I round it to three significant figures, just like I had right here, 1, 2, 3, 3.98 times 10 to the negative 19th power. And so this unit over here for frequency was 1 over seconds, and the unit of the h is j times s. Then once we use j times s and then multiply it by something that's 1 over s, you should be able to see that our s's will cancel because it's an s in a numerator unit times s in a denominator unit, which is really the same as s divided by s. So our unit in the end is just going to be joules, which is the unit of energy. Okay, so an important thing to note here is that you actually got the correct exponent, because if you did the scientific notation correctly in your calculator, you should get an exponent that's pretty close to this exponent plus this exponent. When you multiply two things with exponents, basically you should be able to just add them together to figure out what your guesstimate exponent for your answer is. So if you took 34, if you took 14 plus negative 34, the same thing as 14 minus 34, you'll get about 20, right? And 19 is really close to 20, so that's our guess that this is the correct answer. Because it could be way off. It could be a positive number if you did this wrong or something like that. So that's why I mentioned that. Okay. Then, now we want to calculate our wavelength. Okay, so if we use the frequency to find the wavelength, we can use the equation that has both frequency and wavelength in it. Okay, so that means we can use this equation. Okay, this has wavelength and it has frequency. Okay, and then this right here is a constant, so we know what number we can plug in for that because we already saw that. It's 3 times 10 to the 8th. Okay, so I'm going to plug in to this equation. We have our frequency and we have our speed of light, and all we need to know is our wavelength. So 3.00 times 10 to the 8th power meters over seconds equals the squiggly lambda, and we don't know what that is because that's wavelength and we're looking for that, times the frequency, which is 6.00 times 10 to the 14th 1 over seconds. Okay, so now all we have to do is solve for lambda. So these two things are on the same side of the equal sign, and right now they're being multiplied. So the only way to cancel out on this side and move it to the other side is to divide by this number on both sides. Alright, so that'll cancel here, and we'll have it over here now. 6.00 times 10 to the 14, 1 over seconds. Okay. So you should be able to see here that our seconds are going to cancel when we divide this, and our unit we'll be left with is meters. So all you have to do is put in this scientific notation. Now, I definitely recommend here, you really need parentheses, and you need to know how to do scientific notation in your calculator, okay? Because you could really mess this up if and you'd have the wrong answer for your exponent for sure. So 3 times 10 to the 8 divide by 6 times 10 to the 14th. Okay, I've got, it says 0.000, like a whole bunch of zeros and then a 5, but I'm going to change this to scientific notation. So remember, we want our significant figures, and if you don't see any more significant figures, you can add zeros after the decimal. Okay, 5.00 times 10 to the, since this is a tiny number, it's going to be a negative exponent. And I've got 1, 2, 3, 4, 5, 6, 7 spaces. 10 to the negative 7 meters. So this is my wavelength from my original question, where I started with the frequency. So now I have the energy and the frequency, the wavelength, and I have the frequency. So now I know everything about this light. Now, the one thing about your exponents here is when you're dividing things with exponents, just to check that you got it right, take the top exponent minus the bottom. So 8 minus 14 should give me about negative 6. Negative 7 is really close to negative 6, so we can assume that we did this right. Now, if you got 10 to the 22nd, positive 22nd, then that would be really obvious that this is off. So you can use that as a way to remember. When you're dividing, you can subtract exponents to check if your exponent is correct. When you're multiplying, you can add exponents to check if it's correct. Okay? All right. So that is calculations of light and energy. Now we have one more example problem before we finish for today. And this question is saying that a photon, or a particle of light, is emitted or released from an atom with an energy of 4.25 times 10 to the negative 19 joules. Okay, so even if it didn't say with an energy of, we should be able to figure out that this is what variable? E. Okay, and the way we would know that is because the unit is just joules, which is a unit of energy. Okay, so now it wants us in A to find the frequency, and then after that we can find the wavelength. So, the equation we're going to need is an equation that has both energy and frequency, which we have E equals h nu, or energy equals Planck's constant times frequency. Okay, so we can plug in our energy, 4.25 times 10 to the negative 19 joules, equals 6.626, our Planck's constant, times 10 to the negative 34th, joules times seconds, times nu. Okay, so now we can see that if we want to get nu by itself to solve for frequency, we're going to have to divide by Planck's constant. On both sides. So it'll cancel it over here. Alright, and now we can see on this side that our joules are going to cancel out and our unit's going to be 1 over seconds for our answer. Now again, we can figure out our approximate exponent we should get by taking the top minus the bottom. So negative 19 minus negative 34, that's the same thing as negative 19 plus 34, or 34 minus 19. So we should get about 15 for our exponent, positive 15. So we can go ahead and calculate that. And we can do that with lots of parentheses, like I said before, so that we don't mess up our calculator's understanding of what we're trying to do. 4.25 times 10 to the negative 19th divided by 6.626 times 10 to the negative 34. Alright, so I got something for my exponent that's pretty close to 15. got that my frequency is 6.41 times 10 to the 14th power, and then like we said before, our unit should be 1/second. So that's our frequency. Okay, so we've answered the first part of the question. Now part B, this is all part A. Part B is asking us to find the wavelength. And the only equation that we have so far that has wavelength in it is the equation that was C equals lambda nu. Okay, so we have our frequency now that we can plug in for nu, and we also know that C is a constant. So now we have enough information that we can actually use this equation to get our wavelength. So let's plug in the speed of light, which is 3.00 times 10 to the 8th. And we don't know lambda, but we do know our frequency is 6.41 times 10 to the 14th. And I don't have room to write my unit. But if we want to get lambda by itself, like we've been doing, all you have to do is divide on both sides by your frequency. And so it's canceled over here. 6.41 times 10 to the 14. Alright, I forgot to write in my units here. This is meters over seconds, and this is 1/second. So we can see that our seconds will go away and we'll be left with meters, which makes sense for wavelength, because wavelength is talking about a distance, and so is meters. Okay. 3 times 10 to the 8th divided by 6.41 times 10 to the 14. 8 minus 14, that should give us about -6. So let's see if that's what I get. I've got this number. I'll show an example of changing to scientific notation just so you guys all remember. 3 zeros, 4, 5, 6 zeros, and then 4, 6, 8. Okay. Remember, for scientific notation, I want to put my decimal right here. So it's after the first number. So that'll be 4.68 times 10 to the, okay, this is a very small number, so it's definitely going to be a negative exponent. And I've got 6 zeros, and then I got to move it one more space past those zeros, so it's going to be to the -7. And we just said we expected it to be near the -6 power, so if you got this on your calculator, then you know that you did your calculation correctly. And that's all we have for today.